So an algebraic term is simply what? A letter. So let's look at how that works. So algebraic term. It's what? Simply put, a letter. A letter. Let's start with that simple description, because as we proceed, we will begin to expand on that definition. Now, what numbers are, listen attentively, what numbers are to arithmetic is what letters are to algebra. I'll come again. What numbers are to arithmetic? What numbers are to arithmetic is what letters are to what? Algebra. So for instance, in algebra we're talking about things like A. Is that not? We're talking about things like B. We can write 2A. We can write what? 3B. These are what? Terms. Is that not? You guys started by saying that these are letters are simply what? Algebraic terms are simply what? Letters. But that was just on the surface. We can stretch the narrative a little there. This is 2A, but this is a term. This is also another term. And to be very technical, we call them algebraic what? Algebraic terms. But if I were teaching algebra, I would have written what? Numbers. I see that. So these are numbers. These are what? We call them numbers. These are what? Algebraic terms. So, as you put in all of these ideas together, it will mean that all algebraic terms should have factors. All algebraic terms should have factors. If I write 2A for instance, what are the factors? Because I'm going to be teaching you a very interesting technique. I will follow your conventional book approach. I'm going to teach you something that will shock you. Now look at this. If I write 2A, what is 2A? I will pick 2A to look like 2 times what? A. Is that not? Is that not what it is? The letter talking more about the algebra and the number talking more about the what? Arithmetic. Now, I can pick the factors of this to be what? 1 and what? 2. Is that not? Is that not? And the factors here will just be only what? A. So if I put everything together and I want to write the factors possible here, I'm going to have 1, I'm going to have 2, I'm going to have A, and I'm going to have what? 2A as what? Factors. So the algebraic factors of this algebraic term 2A will now be what? 1, 2, A, and what? 2A. So sometimes if they ask you the algebraic factors, you can just step on and just say A and what? 2A. But if they ask you the factors, you can now list all of this. Is that clear? Is that clear? Okay, the question says, write down the factors of the following algebraic terms. Write down the factors of the following algebraic terms. So the first one you have is what? 3x. Is what? 3x. Now, when you want to write out the factors of this, there's a very simple way I ask my students to do this. Pick this one. Pick this one. Get out the independent factors. These 3 will be what? 1 and 3. Is that not? This one will be what? Just x. So when you want to write the factors now, the factors will be equal to, pick the numbers first, and then use this one to multiply each of the elements. This time this will give me x, this time this will give me what? 3x. So these are the factors, the factors of this algebraic term 3x. For all terms in the algebra, let's watch carefully. For all terms of any algebra, it is multiplied by what? 1. 1 is a number that can multiply all terms, because 1 is such a powerful neutral number that it multiplies anything and doesn't do anything to it. Such a very wonderful guy. So the first thing you need to do when you are giving this, see what you do. You have A, you have what? B. So pick them. Pick the number. Since there's nothing multiplying it, pick 1, pick A, and do what? Pick B, and then pick what? AB. Are you seeing that? Are we watching? The approach will differ as we move from question to question. Now, if you look at this, you have 1, you have A, you have B, and you have what? AB. I see that you have 1 because 1 can multiply anything. You have what? AB. You have A rather. You have what? B, and you have what? AB. So this will solve. So all of these are factors of what? AB. Number 3. How do we handle x squared? Now look at it. This will be x, this will be 1, and then x squared. So the factors of 1 will just be 1. The x squared, you have x and what? X squared. So you're writing out your factors is going to be 1, x, and what? X squared. So you have 1, you have a squared, you have b. So the next thing you need to do is to try to do what? Combine them. You're trying to do what? Combine them. So what are you going to have here? Here you're going to have 1. You're going to have what? A and what? A squared. Here you're going to have what? B. But remember that what you're looking for is what? A squared B. So pick the factors now. Now, these are the possible outcomes you're going to have. So in picking the factors now, please watch carefully. This is where you need to watch. You're going to have 1, you're going to have A, you're going to have A squared. Are you watching?
Yes.
Then you're going to have B. You're going to have AB. I see it. You're going to have what? A squared B. So that concludes the possible outcome you have here. So you pick the 1, 1 first, then you combine them, and then you get your final answer. So that's that. So let's go to the next. 6A. That's question 5, so not that. 6A. Now, what do? You pick the terms, the individual makeup. So this is actually what? 6 times A. Maybe I should change the narrative a little. It's actually what? 6 times A. I see that. So you pick 6, you pick A, you check them out. This one will give me 1, 2, 3, and 6. What does this give you? A. Now, you're writing the factors, so please watch what happens here. I will pick the 1, 1 first. Then, I will not use this 1 to multiply this 1. And that concludes that one. 5AB, so this will now be I see what I've done. First thing, I spread the factors out. Please, when it comes to learning, use an approach that you are comfortable with. I notice sometimes with my experience in teaching children, I notice that a lot of you stress yourself too much. You want to be like somebody who looked at the studying before, and you're just starting today. Just like somebody that is supposed to come into the field of play. You just change your jersey and come to you break your legs. So take it gradually. So I will come here now. What are the factors from here? I have 5, I have A, I have B. This one will be what? 1 and 5. This one will be A, this one will be what? B. So in writing the factors, now because it's getting complex now, so I will change my technique. What should I have done? I've ruled this, I'm changing my technique. So I'll pick the ones I can see first. I'll pick 1, I'll pick 5. Eh? Watch carefully. Under this, I will have what? A. I will have what? B. Watch. Now, under this, I will have what? 5B. I have what? 5B. Now, look at this. Under this, I will have what? A. Under this, I'm going to have what? 5B. I see it. Are we seeing what I've done? Yes. All right. Question 7, x, y, z. So this is equal to what? X times y times z. So what do you have here? This will now be equal to, you pick the 1, 1. This will be x, this will be y, this will be what? Z. And oh, forgot something very interesting. You have 1, you have what? X, you have y, and you have what? Z. Now, I'll pick it out. So, under this one, I'm going to have what? X, I'm going to have y, I'm going to have z. Now, I compare these two. I have what? X, y. I compare these two. I have what? Y, z. I compare these two. I have what? X, z. I compare all of them. I have what? X, y, z. So I will check. In checking, I will count. I will now write them out. So what you discover are the factors of this particular question. Are you seeing that? Alright, so let's take care of that. Now please notice that in handling this topic, there's no particular method. It depends on your level of understanding. There's no particular method. This is the method you must follow. I always try not to go with a particular method because we all have different mathematics background. So what I try to do is to ensure that you're reasoning. That's the most important thing, you're thinking. Now if you look at this question here, this will be equal to 10 times m squared. So I have an idea of what I need to pick out. So I'll pick out 10, I'll pick out m squared. So what I do next is to spread this one. I'll have 1, 2, 10. Okay, so that will be, having done this, we know that this will be what? M and what? M squared. So with that said, I can now use this as a model to write the rest. I can choose to use another model. I can say 1, 2, 3, 1, 2, 5, 10. So I have M, I have 2m, I have 5m, I have 10m. And then I take the last one, I will have what? M squared, 2m squared, 5m squared, and 10m squared. So by what I've done, this will all form the factors I'm looking for. So this is another approach a student can choose to write. It's all a function of how well do you understand the concept. Now attending to this, the first thing I need to do is to spread this out. This will be 25 times p cubed. So I'll pick 25 and try to spread it out based on the available factors. I'll have 1, I'll have 5, I'll have 25. I'm going to pick p cubed, I'm going to have p squared, and what? P cubed. So I will pick these ones out. I'm going to have 1, I'm going to have 5, we're going to have 25. So under this, I'm going to have p squared, and what? P cubed. Under this, I'm going to have 5p squared. I'm going to have 5p cubed. Under this, I'm going to have 25p squared. I'm going to have 25p cubed. So all of these form the factors available for this algebraic term. You discover that the basic knowledge you need to handle this is a strong knowledge of your factors. You need to be good at your factors. Pick this one, break them into the available factors. Pick this one, break them into the available factors. Now, let me clear an idea here. Letters are also factors. 1. And every letter of the English alphabet is treated as what is called an algebraic prime. So all letters, bracket single letters of the English alphabet with respect to algebra are treated as algebraic primes. Algebraic primes. You want to take note of that because that is a very important information, or we call it an Easter egg for greater things to come. All letters A, B, C, D are all treated as prime. Prime. Just as you talk about prime numbers, look at things like 2, 3, 5, and the likes. All letters in their single individual state are treated as prime or prime. So take note of that information. Very valuable information you don't want to play with. So remember the technique. The first thing you need to do is to spread this out. You may not see this in any textbook. And I'm trying to also ensure that modern mathematics require that we don't write too much. So if you watch me, I just make a simple statement and I go ahead. Because what's important is your ability to be able to get the job done. Right? So what you do simply is you say 8. Okay, so this will now be, you take 8, you take D, you take what? E. So, now let me forgive you one very, okay. Now, that's that. So, with this one, I'll come down here. Or another smart student can even do something interesting here. Another smart student can choose to do this. What do you have next? It's okay. I've done it, I've done D, I've done E. Okay, I've not done D. I seen it. I see that. So that's it. So what are the factors now? Notice that what I'm doing, I'm not trying to be too mechanical. I'm trying to also play with these ideas, relax with them, and just try to keep it as fun as possible. Because it's not always about the overly serious whatever. What we're looking at when we solve mathematical problems is that you understand the concept and you can use the concept. That's what's important. You understand the concept and you can use the concept. It's not memorizing the concept. Memorizing the concept is useless. You should understand it and be able to use it. Once you have done that, you have made the teacher a very happy person. Okay, so we come to a new sub-concept which is called common factors and HCF. Like I said earlier, your understanding of algebraic fractions, factors or factorization is built on your understanding of these ideas as they apply to arithmetic. I'll come again, your understanding of when you're talking about fractions, you're talking about factors, you're talking about factorization, your understanding of these ideas in algebra is no different from the idea you have gathered from your arithmetic. So you see on the board, we're talking about common factors. You see, we're talking about HCF. What is HCF? HCF means that among factors that are common to terms, because when you're talking about common now, it means you're comparing more than one term. Look at this. If I have 6, I have 12, I have 18 on the board. These are terms, or in arithmetic they are called what? Numbers. Now, if you look at this, what can divide these numbers? We draw a simple approach, and we discover that 2 can go all through. We discover 3 can go all through. So, invariably, what this means is that the factors that can go through this, or the common factors, put in perspective, the common factors that can go through these are 2, I have 3, and when I multiply 2 by 3, I'm going to have what? 6. So these are the common factors. So where does HCF come in? HCF means that among common factors, there is one that is your Joweri if you are from Edo State. There is one that is the Igwe if you are from Igbo community. There is one that is the Total General of the matter, and that is the 6. So that 6 becomes the HCF, the highest amongst common factors. You know, sometimes when we just give definition, it makes the thing look so weak. But when we try to, break it down, use our small local dialect and things like that, it makes the thing very easy. Among factors, among common factors to these terms, there is one that is the highest, that is the best, that is the biggest. That one is treated as the HCF. So that's what has happened here. This idea we are going to apply in our algebraic factors. Alright, so let's do that and let's go to the next idea. Okay, this is AX, call it basket mouse. This is AY. You all know these comedians very well, even though we are still studying mathematics. And the truth about maths today is that we must also try to introduce what is called fun elements. If I say AY now, everybody suddenly, I say Bobby, everybody suddenly will just relax and feel so happy. Why? It means there's something about their names that triggers something in your brain to work. Now, you have AX, you have AY. Now look at AX. Look at AY. If you look at AX and AY, there is one letter. You know, we said earlier that each letter is a prime. So which letter are you seeing in both of them? It's A. So, what is the HCF of these algebraic expressions? It will simply be what? A. Looking at these ones, which letter or letters are common? It will now be what? A. Alright, so that will now be the HCF of this particular concept. Alright.